Here are some reminders to help you get the most out of your DIVES CD lessons. First, work the problems with me. Work every single problem that I work and take notes on everything that I write on the board. One thing I encourage you to do is on the first practice problem, work that one with me, but then for the second and subsequent ones, pause the CD, try to work the problem on your own, then fast forward to the answer. If you got it right, great, you can move on to the next one. If you got it wrong, rewind the CD, look at how to solve the problem, and figure out how to do it correctly. Next, anytime you need to, pause and rewind the CD until you understand that particular concept. The ability to pause and rewind so easily is what makes DIVES CD lessons so much better than a live classroom lecture, so make sure and take advantage of that technology. Next, remember the purpose of math is to teach you to think and to solve problems, to effectively and efficiently think and solve problems. In the lower math levels, there's lots of mental math. In the upper levels especially, this is the most important purpose of math, is to teach you to think and to solve problems. Next, do all of the problems in the problem sets. It depends on the course that you're doing, but typically you'll do 3 to 5 problem sets a week, so that means 3 to 5 CD lessons plus a test. Next, work the homework problems and your test problems too. Work those vertically. Split your paper in two and work them vertically. And of course, make sure you show your work on your problems too. As you work them vertically, write each step down and write each subsequent step underneath the previous one. And this will help you sometimes to recognize patterns a little bit easier and help you solve the problem better. Also, use a calculator sparingly, only for geometry problems and some word problems. Don't use it for Math 7-6 or below that for any of that. Algebra half and up, use it sparingly. And lastly, have a good attitude. Every day you do school, you have a choice to make. It is your personal choice to have a good attitude, work hard, do your best, or to be lazy, complain, whine, and have a bad attitude. So choose right now to have a good attitude. Dive in, take advantage of this CD lesson, and do your best to learn the math that you're going to learn today. Lesson 70 is about probability and designated order. Probability, what that basically does is places a numerical value on the chance of an event occurring or not. Like maybe when you watch the weather, they say that there's a 30% chance of rain. That's basically a probability. They're guessing that there's a 30% chance that it'll rain, or that 30% of the area that they're talking about will get rain that day. The definition I like to use for probability is the one I put on the board there. It's equal to the ratio of the number of desired outcomes to the number of possible outcomes. And probability, it's used along with statistics by scientists and other people, and it helps them organize and understand a set of numbers. So just like when we were studying range, median, mean, and mode, and we talked about how those help you organize and understand and work with a set of numbers, probability also helps you work with a set of numbers, and that it helps you predict possible outcomes in a numerical way. One way to think about probability is just with simple coins. Coins have a side that's a heads and a tails. The probability of getting a heads, if you flipped a coin, you could just say P for probability and then put an H in parentheses. It doesn't mean P times H or anything. We're just saying the probability of getting a heads. That's just symbols that we use kind of like a function to help us think about the problem. So the probability of getting a heads, if you flipped a coin, there's one desired outcome. We want a heads. The number of possible outcomes are 2, because we could end up with a heads or a tails. So the probability is 1/2 or 50%. There's a 50% chance that we will get a heads if we flip a coin. Probability can also be used in rolling dice. For example, if you had a single die, the probability of rolling a 2, that would be the same as the probability of rolling a 1, and it would just be equal to 1/6. Because the desired outcome, there's just one desired outcome. The number of possible outcomes is 6. So no matter which number that you're looking at on a die, the probability of rolling that particular number is 1/6. Now if you have 2 die, things get a little more interesting. And if you're using the Saxon textbook, there's a table that tells you how to deal with probabilities using 2 die. So now, for example, the probability of rolling a 2, there's just one way to do that if both of the die landed on 1. And so the number of desired outcomes is 1, but the total number of outcomes, there's 6 faces on each die, so you have to multiply those two. 6 times 6. So the probability is 1 in 36 of rolling a 2. The probability of rolling a 3, you just think about it, you could get a 1 and then a 2, or one of the die could have a 2 and the other one a 1. So there's 2 possible, or there's 2 desired outcomes there. There's 2 ways to get the desired outcome, but you still have a total number of outcomes of 36. So it's 1 and 18. So when you're dealing with problems where you have 2 die, refer to that table in the textbook, and that will help you figure out how many desired outcomes you have. You always have 36 total possible outcomes, but use the table to determine how many desired outcomes you'll have. Let's go ahead and do some practice problems now. Practice problem A, consider a single die. What would the probability of a number greater than 3 be if you were rolling that die? What would the probability of getting a number greater than 3 be? Well, just think about it. You would have a possibility of a 4, a 5, or a 6 if you're rolling a single die. So there's 3 desired outcomes there. There's a total possible 6 outcomes. So it's 3 over 6 is 1/2. So there's basically a 50% chance of getting a number greater than 3. Now something to think about here, does that mean if you rolled the die that if you rolled it twice that one of those 2 times you would get a number greater than 3 for sure? No, that's why it's called probability. Probably you'll get at least one number greater than 3 if you rolled the die 2 times, but you may not. The value that you calculate with probability, like in this example, 1/2 or 50%, that just gives you an idea of what might happen. The more times you perform the experiment, though, the better chance that the probability that you get, that you calculate here, will be actually what the experiment reveals as well. For example, if you rolled the die 200 times, then there's a greater probability that 100 of those 200 times you would get a number greater than 3. If you only rolled it 4 times, then there's not as great of a chance that the probability would be 1/2. The more times you repeat the experiment, the closer it gets to that actual calculated value that you make. That's why scientists, when they are doing an experiment, they want to collect a lot of data, because the more data they have, the better it works when they're calculating probabilities and using statistics. Let's do another one. What is the probability of rolling a 3 and then a 7 using 2 dice? Well, what we do on problems like this, we call these independent events. If you had 2 pair of dice, the probability of rolling a 3 the first time is totally independent of getting a 7 the second time. And when we have events like this, we multiply the probabilities together of the individual events to figure out what the total probability is. So in rolling a pair of dice, you need to use that table in your book to help you figure out what the probability is going to be, or at least what your desired outcomes are. So when you have to, if you're wanting to roll a 3, there are 2 desired outcomes there. The total possible is 36. And then for a 7, there are 6 desired outcomes there, and a total possible, again, of 36. So we multiply these 2 individual probabilities together. Let's go ahead and simplify them first. We'd have 1 over 18 times 1 over 6. And so the probability of rolling a 3 on one turn and then getting a 7 on the next one is 1 in 108. So as you can see, your probability goes way down when you start doing these independent events, when you want to get a combination or a certain order of events to happen. That's what the designated order means in this lesson. If you want to get this designated order, a 3 first, then a 7, your probability goes way down of that event actually occurring. So what that means is if you rolled those dice twice, like 108 different experiments of rolling the dice twice, you may get one time in that a 3 and then a 7 in that particular order. Let's do one more problem. In this one we have a spinner. That little red dial is like a spinner that spins around that set of numbers. What would be the probability of that spinner landing on a 2 and then you spin it again and it lands on a 3? Well, these would be considered independent events, and there's this particular order that we want the events to occur in. Get a 2, spin it again, get a 3. Well, look at the individual probabilities. The probability of landing just on a 2 is 1 desired outcome over 4 possible, because there's 4 numbers there. And then we multiply that by the probability of landing on a 3. That would be 1 over 4 as well. And so the total probability would be 1 over 16. So again, as you can see, when you have more than one event that you want to happen in a certain order, your probability decreases quite a bit compared to just the individual probability. So again, that means if you did that experiment of spinning it 2 times, there's a chance that one of those experiments out of 16 you would get that order, 2 then a 3. And that doesn't mean that you would get that 2 and a 3. You may get 2 times that would happen out of 16 experiments. You may not get it at all. Probability just gives you an idea of how difficult it is to get that particular event to occur. So probability is like odds, like in gambling, like for a lottery or something. What are the odds of winning the lottery? It's the same idea. It's a probability. But that is definitely an application of probability, is in gambling. I don't gamble. I think gambling is a waste of money, but that is an application of probability. Okay, well that's all for lesson 70.